This is section 6.4 on partial fraction decomposition, and it's in your class notes, page 7. When you are adding two fractions, you get the common denominator, and so for this one it would be x plus 4 and x minus 3. So then with the first fraction, you need to account for not having an x minus 3, so you'd multiply 3 times x minus 3. And then for the 2, you have to account for x plus 4. Okay, so then you're going to FOIL out your numerator. So that gives you 3x minus 9 plus 2x plus 8. And then in the denominator, I'm going to keep it in the factored x plus 4 and x minus 3. Okay, then you combine your common terms. So that's 3x and 2x, which is 5x, and a negative 9 plus 8, which is negative 1, and the denominator is x plus 4, quantity x minus 3. Okay, so then if I FOIL out the denominator, that gives me an answer of 5x minus 1 all over x squared plus x minus 12. So this process of adding two fractions together and getting to this one fraction is what you guys had back in Algebra 1 or Algebra 2. So for partial fraction decomposition, you're actually going in the opposite direction. Okay, so you're starting with a problem like this, and then you want to rewrite it so that it looks something like this. Okay, and the purpose of this type of exercise is that you'll be needing this skill in order to do some calculus problems. Okay, so let me go through a few terminology. So the reverse procedure of starting with the rational expression and writing it as a sum of difference is referred to as partial fraction decomposition. The two simpler fractions are called partial fractions. So in this problem, this is the partial fractions. A rational expression is the ratio of two polynomials, where the numerator is p of x and the denominator is q of x, where q of x does not equal 0 because you can't divide by 0. If the degree of p, or the numerator's degree, is less than the degree of q, which is the denominator, then it's called a proper fraction. If the degree of p is greater than the degree of q, then it is called an improper fraction. So the example that we have up here, since the degree of the numerator is less than the degree of the denominator, this is called a proper fraction. Okay, so we're going to do some examples now using this procedure of partial fraction decomposition. So the first example is called distinct linear factors, and they are non-repeated linear factors. All right, so this is what's given, 5 over x squared plus x minus 6. And the first thing you'll do is to factor completely your denominator. Oh, actually, the first thing on this is you want to make sure that this is a proper fraction. So the numerator's power has to be less than the denominator's power, which it is. Okay, then you factor the denominator, so that gives you x plus 3 and an x minus 2. And then up in the numerator, you keep the 5. Okay, then you're going to split up the two factors as two separate fractions. So you have an x plus 3, and then you have an x minus 2. Now, in order to keep this as a proper fraction, since this is a linear down here in the denominator, the numerator has to be a degree that it's less. So if it's a first power in the denominator, then it has to be a constant up in the numerator in order to be kept as a proper fraction. So I'm going to call that numerator's constant as a. Then you have the denominator here is x minus 2, which is also linear. That means that the numerator has to be a constant, so I'm going to call that as b. Okay, so your task is now to figure out what a and b are. And I'm going to use what's called the Heaviside method. And this is what the Heaviside method is. You're going to choose an x value that will make one partial fraction a 0 in the denominator. Okay, so I'm going to look at this one here, and I'm going to ask myself, what will make this x plus 3 as 0? So I'm going to choose that number, and the number is x is equal to negative 3. Then what you do is you go back to the left side here, where you have it completely factored, and I'm going to cover up that term of x plus 3. So I'll use my finger and just cover that up. And then you place a negative, x is equal to negative 3 in for all of the x's here, which is only this part right here. So that gives you 5 over and a negative 3 minus 2, so that's negative 5. So it's 5 over negative 5. So you get negative 1. And that's going to be your answer for the numerator of this partial fraction. So a is equal to negative 1. And then I'm going to do the same thing to this factor. So what makes x minus 2 equal to 0? And that is when x is equal to 2. Okay, so then I'm going to cover up now this one and put in 2 here. So that gives me 5 over 2 plus 3, which is 5 over 5. So b is equal to 1. Okay, so that's going to be the numerator here. So then my partial fraction on this is negative 1. I'm just substituting it in for this. So it's negative 1 over x plus 3 plus 1 over x plus 2. And so if you were to go in the reverse process of combining these two fractions, you should get back to this. And I'll leave that for you to do as an exercise. Okay, the second example that we have is called a repeated linear factor. All right, so for this one here, I have the denominator that is already factored. And so if I would multiply this out, the power in the denominator is 3, and the power in the numerator is 2, so that means that this is a proper fraction. So now I'm going to split it up, and I have 2x. And for this one, since this is a repeated linear, I have to account for the highest power, which is a second power, along with all the powers that are underneath it. So I have to have a first power here. And the reason is that if I were to combine these three fractions, the common denominator would be an x plus 1. So you have to, x plus 1 squared times a 2x. So you have to include both the x plus 1 and the x plus 1 squared. Okay, so to keep this as a proper fraction, I have a constant up on top, a, and then I have a constant b on top, and then a constant c on top of this. Okay, so for this one, I can use the Heaviside method, the cover-up method for a and c. Right, so what will make this 0 is x is equal to 0. So then I cover up this and put in 0 for this. So this drops out and this drops out. So I get a is equal to negative 1. Then I'm going to look at what makes this one 0, and that would be a negative 1. So if x is equal to negative 1, I'm going to cover up this side here. And so if I put in a negative 1, that gives me negative 3 up on top, or 3 up on top, and then in the denominator I have a negative 2. So that will give me a c value of a negative 3/2. Okay, so the Heaviside method works quite well for a and c. Now the problem is with b. So for b, I'm going to substitute a is equal to negative 1 and c is equal to negative 3/2, and then leave b as it is. So I just rewrote this down here. Okay, so I have 4x squared minus 1 over 2x quantity x plus 1 squared. So that's this. And then that's going to equal a negative 1 over 2x plus b is what I still don't know. So I'll just leave it as b over x plus 1 plus, and then c is a negative 3/2 over x plus 1 squared. Okay, now I'm going to multiply the entire equation by the least common denominator. Okay, so that's what this LCD is. So the least common denominator is 2x times x plus 1 squared. All right, so I'm going to distribute this to every single term. So distribute it to this first term, distribute it to the second term, or the first term on this side, distribute it to this term, and distribute it to this term. Okay, so when I do that, that takes me up here. So if I multiply this times this, the denominator here, and this will just cancel out, which will leave me with 4x squared minus 1. Then for this one, I'm going to multiply this times this, so the two x's will cancel out, and then I'm left with a negative 1 quantity x plus 1 squared. And then I multiply this by the b over x plus 1, so that gives me b times 2x times x plus 1. And then for my last term, multiply this times this, and the x plus 1 squared will just cancel out, so that leaves me with negative 3 halves times 2x. Okay, next I'm going to just FOIL everything out on the right-hand side. Okay, so the left side just stays 4x squared minus 1 equals, I FOIL this out and negate everything. So that gives me negative x squared minus 2x minus 1. And then for this to distribute this 2bx to the x plus 1, so that's 2bx squared plus 2bx, and then multiply these two together, and that gives me a negative 3x. Okay, so now what I need to do is match up all of the powers. So the only one that I'm really concerned with is this b. So see how you have a 4x squared here, I have a minus x squared here, and then I have a 2bx squared here. So I'm going to make an equation with just my x squared terms. So you match up the powers on the left and the right side. All right, so that gives me 4x squared, and then I have a minus x squared plus, and this one here is 2bx squared. So then I'll bring the negative x squared to this other side, and then I'm also going to divide the entire equation by a x squared. So I could just take away the x squares because I'm just interested in the coefficients. So then I'm left with 5 equals 2b, and so then solve for b, and b is equal to 5 halves. All right, so then my overall answer for this partial fraction decomposition is negative 1 over 2x plus 5 halves over x plus 2 minus 3 halves over x plus 1 quantity squared.